Mr. President, call on line 4.
Hello. Hello, Mr. President. You and your scientific community have not respected us the past 80 years. Soon you shall see the proof of our theories. You have 20 minutes to eradicate all quantum chemists whose theories are too convoluted, confusing, and intuitive, or face the consequences. This is your only warning.
Who is this?
Time starts now.
Darn it! Get me CTU!
Hello, sir. Sir? Sir, it's my day off. I understand, sir.
Jack Bauer.
Jack, I have a case for you. It's a bomb going off in 20 minutes in Simsbury, Connecticut.
Terrorists here? In Simsbury, Connecticut? What? They've got a bomb?
Yeah.
I'll call you back. Military grade cable. Looks like it's German. Don't move! You're bleeding out. You're gonna die in 30 minutes if you don't get to a hospital. I'm your only hope. Now tell me what I want to know. Where's the bomb?
It's the pipe.
It's the pipe. Where? Where? God damn it! Hey, Mike. Matt. 123 Oak Street. I just took out 2 German guards. They must be guarding the bomb.
It's in the basement of the building. There's a back door in front of you, but going through the front is safer.
No, there's not enough time. I've got to go in right now. Hey, Mike. Bauer. I've got an Orion bomb here. This must be what they were talking about.
Matt, Jack just found a bomb called the Orion. Do you know what it does? I'm not sure.
Yeah, the Orion series, but why on earth would anyone use that? It's really old. It can only be diffused by calculating the spin of an electron.
Okay, so our only options are plus 1/2 and minus 1/2, right?
Right.
So we would calculate that using quantum chemistry?
Normally that'd be true, but in this case they stopped producing the minus 1/2 models many years ago.
Oh, Jack. They stopped producing minus 1/2 models a long time ago. It's plus 1/2.
Plus 1/2? Okay.
computer center equipment. Alright, that's Simsbury High School.
Alright. Is that all I need to do here?
Yes.
Alright.
Mr. Horowitz, please fax a briefing to the President. Thank you.
And here are the facts from the field, Mr. President.
Oh, thank you, thank you. What is this? I can't read this. Get me CTU on the vid chat now.
Chemistry. Are we rolling? Oh, okay. Hello, Mr. President. I'm here to explain to you the differences between quantum and classical chemistry. This is because old school classical chemists are trying to undermine the foundations of modern chemistry by trying to disprove our current notions with old notions. However, as we all know, quantum chemistry is really the most effective way to understand the small-scale structures. However, just to explain briefly the differences between classical and quantum chemistry and the foundations behind that, according to classical chemistry, you have particles, I'll show this up in a minute, which have a distinct position and velocity, as we can see here. However, according to quantum chemistry and mechanics, there's what's called a wave function, which describes the quantum behavior via probabilistic effects. So, for example, just using physics for an example, because it's on a larger scale, we can see that a pencil behaves almost uniformly. You can predict exactly where it is and exactly how it's falling. Meanwhile, according to quantum mechanics and chemistry, when every single particle has a probability distribution of where it might be. You can't exactly say it's at one point. There's a small chance over here, a small chance over here. And in this diagram example, over here is most likely a point. And then it has a very, very small chance of being over here and over here, but in all likelihood it's over here. Now, when we try to observe these things, if we try and, let's say, trying to see where the electron is in its shell, which is what quantum chemistry is frequently used for, the wave function collapses to a single point. And so we only see the particle as one single point. This is what's called Heisenberg's uncertainty principle, because there's a trade-off between how much we know about its position and velocity, because we only see part of the wave function. And where we describe, and now chemists and physicists have developed very complex ways to describe it. It's using what's called the partial differential equation. If you can get a zoom up at that. Yeah. Now, it requires a whole lot of math and a whole lot of physics to understand this thing. Many years of graduate school and college. However, just to briefly summarize it, it basically describes the wave function and how it changes over time. This complex wave function here. Every particle has a different wave function. Now, what the evil scientists are trying to show is that this isn't how it behaves, and how really you can just express it in point particles and not wave functions. However, as modern physics and chemistry has shown, you can't. And we should hopefully be able to undermine their devices using this newer form of quantum chemistry.
Now I understand it. Quantum chemistry. It all makes sense.
There's a residential sector in Firetown where improvised incendiary explosive has been reported. You have experience with that, right?
Right, I'm a member of the EDCU.
Alright, can you go check it out?
I'm on it.
Thanks. Be careful.
Yes.
lost Jack's signal. I need CTU over there now.
Oh, we lost them.
Hello, Mr. President. I've heard that you've detected one of our bombs, but that is not the only one. We have a massive bomb underneath Simsbury, Connecticut. If you do not acquiesce to our demands and give us the heads of all quantum chemists in the United States, we will use it. This is your only warning. You have